There we go. Perfect. Great. Amazing. Thank you. Hi, everyone. My name is Dan Watson. And as mentioned, I'm one of the co-founders, alongside with Nadia, actually. She's got many talents, of the Safety Net Technologies company. So I actually started working on this about 14 years ago now as a student. And it was my final year project. And it was looking at the world and seeing what's going on in the fishing industry. Why are people so angry about it? Why are there so many problems? And as a mechanical engineering student, what can I do to try and get involved to try and create some things that make it better? So this involved a year's worth of study in the first place, of going out on fishing vessels, meeting with scientists, really trying to understand as much about the problem as possible so that I could start to build some sort of technology to address one of the problems in the space. And there are lots of problems in the fishing space. Documentaries like Seaspiracy have come out in the last year or so that have shown some of the high-level issues around the problems in fishing and how you feed a large population of people with food from the oceans. Or ocean, I should say, because it's one ocean. Everything is connected. But some of the issues that started to encounter when looking into this industry were things like 9.1 million tons of fish discarded every year through the global fishing industry. So that's fish that's caught, that is unintended. So it might be endangered species. They could be too young, too small, the non-target species of a fishing operation. Then thrown back into the water, usually dead, which means that we're actually depleting fish stocks for no reason. The only people that benefit are the seagulls and the seals. Additionally, for the fishing industry itself, that employs a huge number of people around the world, they're losing money every time they make these mistakes. And this becomes unsustainable for them as operations to actually be able to keep going as businesses and support coastal communities and people in jobs in the sector. And finally, we have this growing population in the world, which is growing very, very fast. And people need to be able to eat. And if you consider that 1 in 5 people in the world relies on protein from the oceans in order to eat, if we're depleting that so fast and we're unable to replenish it, how do we keep feeding people in a sustainable way? And I think we have to be very realistic about this. In the last week, I was in Lisbon at the UN Ocean Conference, and this was delegates from all over the world coming together to talk about the state of the ocean and how we're going to start working to fix it. And I think what we identified is that despite all of the best will in the world, we're still very early on in that process. There's still a lot that needs to be done to start countering these problems. And even having been working in this space for 14 years, we've seen the changes gradually happening, whether it's in policy or technology or other things. But there needs to be a lot more done because we're facing a future right now which is quite bleak, to be completely honest. There needs to be a lot faster, a lot more invested in this space to make it better. So with that in mind, these are some of the issues that Safety Net tries to address. And one of the biggest ones is this bycatch issue, so putting fishing gear in the water and catching things that you don't intend to. And this has happened for years. It's happened for thousands of years as we've fished. But because the scale of fishing has got so much bigger, the problem has also become bigger with it too. And this leads to things like overfishing as well, where we're fishing in a very badly managed way in particular fisheries, where we're catching too much fish that is unsustainable. It means that the stocks can't replenish, they're not abundant, and we're actually running out of fish in some fisheries around the world. For instance, in the last few weeks, the mackerel fishery off the coast of Canada has been closed down because we're taking fish from that fishery way too fast, and they're unable to actually rebuild the stocks over time. But it's not only us who cares about this, the fishing industry cares too. And yes, let's be honest, there are a bunch of different reasons why people are interested in actually fixing this problem. In some cases, if I'm an artisanal fisherman like Pak Paiso here in Indonesia, I really just want to be able to keep going to sea to catch fish so that I can eat and I can feed my family and my community. If I'm one of the more industrial fishing fleets, I have investors, I have commercial interests, I have employees, I have people I need to be able to keep supporting through my business, and maybe my interests are more financial. And while it's not the optimal way that we'd like to view the world, it can be a very useful lever in how we can achieve real change in the sustainable approach to fishing in the world. And again, Safety Net is working mainly on industrial fisheries and also artisanal fisheries, but there are loads of interesting different approaches to how we feed people from the oceans too. If we look at the aquaculture sector, for instance, It's growing really, really fast, fish farming, because this is a different way that we can start to raise fish and protein and other organisms. We're looking at seaweed as well, having this boom in terms of people investing in it and using it in terms of creating businesses. Because seaweed can be grown in lots of different places, it can be turned into many different products, whether that's pharmaceuticals or food or other things, or even plastics. And we're starting to get much more creative with how we use the resources in the ocean, but in a way that's balanced and doesn't mean that we run out of them in the immediate future. So in Safety Net's lens, we're addressing fishing by calling something precision fishing. So in the past, if you imagine we went out to sea, fishing is actually the last hunting operation that the world does at a large scale. So this is where we chase animals around, we catch them, we bring them back, and we do things. Now that's changing with aquaculture, but it really is like the last hunting operation where we spend resources to gather things. But it hasn't really been that precise, and it hasn't really been that well managed. If you imagine that what you're doing in some cases is you're taking a big net, and you're putting it in the water, and you leave it down there for a while, and okay, well, what's happening when that's going on? You bring it back up, and then you can see, and you can start to try and fix the problems that you've encountered. So we're starting to do things like help fishing crews with different technologies by enabling them to observe the fishing activities as they progress. So where is the fishing happening? Like, how is it taking place? To measure the change in the ocean, so the environmental data, for instance, like how was the temperature? What was the salinity like? How did that affect the presence of different species? And if we know that, can we plan better in the future to avoid some species and catch other species? And once you know some of this data, how do you respond to that? So if you know that you need to fish in this spot to catch the fish that you want, but you think there'll be other things there that you shouldn't catch, what tools can you deploy, or knowledge as well, to avoid them or have a higher chance of avoiding them? So this to us is what precision fishing means, and it's the world that we're trying to build where humans and the ocean can thrive together. So step one for us, observing. Now, I mentioned throwing a bag into the water and not knowing what's going on. So our first approach is to say, okay, well, what if we could give fishing crews eyes under the water? We give them a camera system that's affordable, it's very robust, it's very rugged, the ocean isn't going to destroy it, and it means that much like we use cameras on a daily basis here, you can see what's happening and you can start to understand it better. Because at the moment, you put something in, you take it out, you don't really know what happened in the intervening time under the water. But if you can see what different elements of the fishing gear were effective in making them more selective, you can start to make them bigger or smaller or move them and make them more widely used because you have evidence to show that it's a very effective technique. So for us, this looks like this. We put our catch cam into the water for fishing crews, and it starts to look at what's going on in the fishing gear. You can start to see when fish arrived, how they escaped, how they didn't, which is also unfortunately true, but something we aim to change. But what it gives you is evidence and data to make those changes responsibly, where currently it's a bit of a luck-based thing. So next up, we're working on measuring the ocean. Like, why do different things happen in different places, and how can we start to use that in our planning? Because the ocean is absolutely huge, right? But fishing happens in very predictable places, mainly around the coasts of different countries, near to the shore, where the fish live and they breed and they grow. And so what we know also is that the data collection in those particular areas is very, very hard to do. You can't really use satellite data because the water is so mobile and it moves around so much, and there's things in it that make it hard to measure. And also, if you try and do this like with individual fishing vessels, for instance, or research vessels, it's so large that you can't really get across to those places very reliably. So we thought, and this is the thing that we're doing, well, why don't we piggyback on existing operations and existing effort? We can use fishing vessels as scientific platforms for data collection. So we're building these sensors called Enki, and it's a module that's very adaptable, and it can fit onto a fishing gear. So when a fishing vessel goes out to sea, and it puts its nets in the water to conduct its fishing, it's also getting data for us, so that we get this very high resolution in terms of time and space, data from around the ocean that we didn't really have access to before in a way that could be achieved easily. And we can use this to look at what was happening during fishing operations. But if we measure it once and then use it many times, we can supply this to climate data scientists, we can supply it to weather scientists as well, and different sectors that are interested in the ocean space to enrich our understanding of the ocean and how we can respond to it better and also manage it better, because that's the ultimate goal here. So the device goes in the gear, it's put down, it's linked to an app. When it comes back up, it wirelessly transmits the data off to a server. We can start to aggregate that and do much more with it than we ever could before. because there really wasn't that connected set of data before. So finally, we now know, let's say, we succeed in our first goals. We can see under the water, and we can understand more about what's happening in the space. So what next? Well, we have to be able to respond to that knowledge. So we know that, for instance, over here things are going well or badly, or we know that this thing is coming into our fishing gear, and we need to change that. So fishing crews, despite maybe knowing this stuff now, have limited control over what happens all the way under the water when they deploy their fishing gear. That can be for multiple reasons. One, the gear can be very far away. Two, it can be left there for a very long period of time, and they can't be next to it the entire time to make sure that everything's working properly. So we build things that can actually automate that or make it easier for them to manage these processes. And the first thing that we built was called Pisces. So Pisces is a light. This is going to sound a bit weird and sci-fi, but it's a light that fits onto fishing gear. And the reason that we do that is because we know that fish can be attracted and repelled to fishing gear, or in different ways, using lights, depending on their species, depending on their age, their gender. And we can actually use those behavioral responses to control how they move around fishing gear. So as an example, someone like Pak Paiso from the earlier slide, the guy in Indonesia, might deploy a fishing net, a gill net, in the water. And the whole point of that net is to be invisible, right? It means that fish are swimming, they swim into it, and he catches the fish, and that's great. The problem is that it's also invisible to other marine species like turtles and dolphins and sharks. So what we are able to do in that context is that we can take the lights and we can light this thing up like Las Vegas to a turtle, because we select the wavelength of light that the turtle can see very, very clearly, in this case either green or UV. But the target species that are being sustainably caught can't see it, so they continue to be caught. His livelihood is maintained, he can keep feeding people, but the turtle can see this thing and be like, all right, I'm out. I don't want anyone near this, and swim the other way. Again, this sounds crazy, but the evidence completely supports this, and we've seen fisheries where 50 to 80% of bycatch reduction of turtles has been achieved by implementing lights into these systems. And we've seen them in other fisheries too that we've also worked in. So it's an interesting science, it can be applied really quite well, and this is the first of the responsive technologies that we've built as a company. You can actually see it being deployed here in the Mediterranean by an Italian organization. So this is sort of what it looks like. You put it in different places on the fishing gear, deploy the gear as you normally would, and it's very, very simple. Just leave it to do its thing, and it does the job in selectivity. So that's all the technologies we're working on. We're still working on it 14 years later, I think, because this is still such a huge and pressing problem that needs to be solved. It's a very slow-moving industry. We are doing our best as a company to build things to make it faster and easier to respond to the change in ocean states. I mean that in 20, 50, 100 years' time, my nephews and nieces can still eat fish in a responsible way and actually be able to treat the oceans as good stewards too, even if they're not the ones directly fishing. So that's what we're doing at SafetyNet, precision fishing for a sustainable future. Thanks for your attention.
All right, Dan, thank you so much. I do have some questions for you. Well, the first is a curiosity of mine. You mentioned this last technology, Pisces, and I was curious to know how many devices would you need to put on a fishing net to avoid catching turtles and other species that are not the target? So on average, how many would you need?
Yeah, so it depends on the fishing gear. If you're working with like a net, like being towed off the back of a vessel, we normally have between 5 and 10 devices in that gear. So it depends on where you put them, but probably 5 to 10 in that kind of scenario. On a gill net, because they tend to be quite long, you need sort of smaller devices, but more of them, probably about 10 to 20 meters apart. And we actually have a project coming up in Latin America very soon, which is going to be testing the deployment of those lights in gill nets. Because for us, the biggest problem, not problem, but like the thing that we need to solve is how you deploy that type of fishing gear or that type of technology in a well-managed way in small-scale fisheries. Because there are so many incentives that you need to align through government, through the marketplace, through the fishing community as well, to make sure that these things are reliably put out there. And then there are technology elements that we need to fix, which is like make it super easy to use, very affordable, easy to recharge, that kind of stuff, so that we are making sure that we're not adding potential more problems to the ocean space, that it becomes a very delicate and complex thing to try and solve. So in industrial fisheries, it's much more straightforward. There's regulation, there's financial incentive. In the smaller scale fisheries, it takes a bit more work. There's more nuance to how we actually deploy that. And that's what we're exploring in our future project.
All right, thank you. I was actually going to ask you if you could share a project with one of those small-scale fisheries, but I think that's in the future.
Well, we've done some in the past as well. So we worked in Peru. We worked with some small-scale fisheries there to understand what the technology needs would be and also what the fishing needs would be. Like, what incentives could we align with? We did some work with Pakpaiso in Indonesia, so in a place called Muncah, which is on the east of Java. So it's this really, really busy fishing port with thousands of small-scale fishing vessels. And that was trying to avoid capture of mobula rays, so a cousin of the manta ray. I think it was the swimming crab fishery there. And so that was, again, deploying lights to see what could they see that the target species couldn't see, and could we actually find ways to repel them.
All right. Well, thank you so much, Dan. It was very interesting. Thank you.
Thanks for having me.
E damos por terminada aqui as sessões no palco Santander. O Greenfest não termina, todavia. Continuamos com mais atividades aqui no Fórum Cultural de Irmesinde. Portanto, se estão por aqui, venham fazer-nos uma visita. Temos imensas atividades para a família, muitas atividades também de wellness, bem-estar, show cookings. Portanto, não percam a oportunidade de virem até aqui e aprenderem também um pouco e partilharem connosco sobre o tema da sustentabilidade. Queria agradecer aos oradores e ao público, tanto aqui presencial como lá em casa, por nos terem acompanhado e até breve. Teremos um próximo Greenfest em setembro, em Carcavelos, portanto fiquem atentos. Podem ver toda a informação no nosso site em www.greenfest.pt. Muito obrigada e até breve.